Hello, today we're going to continue after food chains to kind of expand into food web notes. So a food chain, again, shows one possible path which energy can move through an ecosystem. But just like us, we don't eat the same food for every meal every single day, neither do most organisms. So those producers and consumers are going to be part of many chains. It's going to be more of a realistic way to show how that flow of energy happens and show that interaction between all those different organisms. So food web is going to consist of many overlapping food chains in an ecosystem. So here's our first example. You can see we start down here with all of our producers. These are all parts of plants. And then as the arrows point to another organism, that's showing, remember, who is doing the eating. Okay? So this is kind of a more realistic way to show what happens in a community between those different biotic factors. So you can see if we were to pick out one food chain from this food web, if I started here with nuts, and then we follow our arrow over to mice, and then we follow arrow to wolf, and then we follow it to the bear. That would be an example of one food chain in that food web. Okay? Another example would be if we started over here with blossoms, they would go to insects, to toad, to skunk, to the red fox, to the wolf, to the bear. That's another food chain that we could pull out of this food web. So a few things to keep in mind. We start at the bottom. These are all producers because they're part of a plant. They, remember, get their energy from the sun. The insects, the birds, the rabbit, the mice, the deer, and the bees are all considered first level consumers because they all have an arrow pointing from a part of a plant. An important thing to keep in mind with food webs is that some organisms can be considered several different levels depending on which food chain you're following. For example, if we follow this food chain from nuts to mice to wolf, it's a second level consumer. However, if we go through this level, from rabbit to red fox to wolf, that would then make it a third level consumer. The bear, if you notice, has no arrows pointing from it. If there are no organisms that are eating that animal, then they're considered a top predator. So this bear is not being anything else. If we look at an energy pyramid, this is another way of representing kind of one specific food chain or web. And the important thing to think here is about the available amount of energy. So remember, those arrows are showing that transfer of energy. We start with the sun. So if we think about it, our primary producers down here at the bottom of the food energy pyramid are going to have the most amount of energy because it's coming from the sun. So as we go up, as we continue into first and second and third level consumers, even tertiary consumers is the same thing as third level, that available energy is going to decrease. So if we started with primary producers having 100% of the energy, it's going to decrease by a power of 10 each time. So this would be our first level consumers are already down to 10% available energy, secondary going to be 1%, and tertiary or third level is already going to be 0.1%. So an energy pyramid is going to represent the amount of energy at each level in an ecosystem. So you still have your producers at the bottom. You have your primary consumers or herbivores, first level consumers. At the next part of the pyramid, your carnivores or secondary consumers are going to be the next part up, and then your tertiary or third level consumers or your top predators are going to be at the top of the energy pyramid. So they are starting with the most amount of energy. So as you get up, that's why it's the smallest part of the pyramid, they have the least amount of energy available. So that's what we need to know about energy pyramids. As you go up in each of those levels, there is a large amount of energy that's going to be lost. So if you think about it, we go back to our example here. Think about how much grubs would have to eat compared to what the jaguar would have to eat to get their available energy. We're going from 10% all the way down to 0.1%. So that's why we think of some of those bigger organisms needing to eat a lot more because they're getting a lot less energy because it's passed through each of these different levels. And that's what you need to know about your energy pyramids and food webs.